In. I assume people are going to filter in. So today we are talking about TypeScript. It's my favorite language, in case it wasn't clear. I think it's a really smooth developer experience. It's got amazing tooling. It fixes errors before they hit production. Everything about it's great, with one or two minor exceptions. But before I jump into that, I wanted to revisit promises and async await, because I did not do a good job of covering it yesterday. So square one, I'll try to keep it not too in-depth for stuff we've covered before. Anytime you make a call to something that takes time to transmit data over a network, the computer can't immediately deal with the object that it gets back. So if I say, get my list of users, and then my next line of code says, display my list of users, you've not yet received the actual data of the users that you're getting. So if you try to display it, depending on how you do it, something's going to go wrong. What we have to do, and what they did in the past, was rely on something called promises. So instead of, for example, number, if we're trying to get a number over a network, we don't just get a number, we get a promise of a number. What a promise is something that can be in three states. A promise can be pending, which is when it's still going on, the data's still transferring, etc. It's still being processed, whatever you're doing to it. A promise can be resolved, which means, great, we got it, we did exactly what we were supposed to with it, and then it follows some resolution function, which is already defined in the promise object. Alternatively, if something went wrong, it's rejected. So we have three states: pending while something's happening, it goes to either resolved if it went well, rejected if it didn't, and at that point, we now get another promise. So it's a little bit counterintuitive, but promises lead to more promises. That's hopefully what this chart represents. I'm going to show you with some code. It'll make it a little bit easier. And promises aren't easy to work with. We have async await now, which is a feature that was added to the language to sort of avoid some of the things you're about to see. So I'm just going to show you like an actual example of how we would do async await here. So let me make this bigger. So we're going to query this endpoint. Basically, we're just trying to get a JSON object from this endpoint here. I found this is an API that you can query right now on your machine. This JSON placeholder, et cetera, website. So we're going to do const. So actually, we're going to do the awaits later. So fetch this. So this will get the first promise, which is just a promise that we're getting from this API. Then we have to do something to it. So the syntax is fetch dot then. So if we see dot, you'll immediately see there's three things that we can do here after a fetch call. We can do a dot then, dot catch, or dot finally, or just finally. Dot then is when things went well, when it's resolved. So if we resolve, we'll do a dot then. So we need parameters here. The first thing is this is a function. So we need to pass something in. Dot then will be data. We're just going to call it data. Will lead to, if we look at it, it's just going to be pretty simple. We need to JSONify it. So we have this promise request. We need to turn it into a JSON form. So it's just data.json. So we've gotten the request. Data is actually of type request. It's a special type, and we'll talk about it a tiny bit in TypeScript. Now we're JSONifying it. If we try to print it out immediately, it's not going to work. Because it resulted in another promise, we need to now deal with this promise with a dot then call. I know this is complicated. It'll be much easier when we move to async await. So dot then, we're going to pass in the JSON. Again, this can be called whatever. So this is a function. We have the arrow. And let's console.log this guy. Dot then. I missed the closing parentheses. There we go. Console.log JSON. So I'm going to run this real quick. Hopefully I didn't do any syntax errors. Great. Is this big enough you guys can see good? Cool. So we see here, we got a JSON object back. You see those brackets mean it's an object. User ID, title, completed, great. But this is only dealing with it if it resolves. What happens if it's rejected? Well, that's when we need to do a .catch. Typically, the syntax, you can say whatever you want. Most people will type error for error. So the error is the parameter here. It's what we get if there's an actual .catch. If it catches something, it'll be an error. Let's just console.log. Error. And so on and so forth. Now this first catch refers to the first then. So this would be if we get an error on actually the fetch call itself. If we want to do another error and make it a little bit more robust, it'll be error 2, we can say. I missed a bracket. Oh, nope. Error 2. There it goes. So this would refer to any errors when we JSONify it. As you can see, this is already hard to read and we're not even doing anything interesting. We're just logging it. Imagine if there was some logic in this function. Instead of logging it, let's do transform data, do more stuff, return some object type. It gets pretty unreadable pretty quickly. And that's why they added async await. So I'm going to show you async await now, which hopefully will make a little bit more sense or be easier to read. Now, we can just do fetch on a line like that. We don't have to wrap it in its own function. If we try to do async await outside of a function, can't do that. It's got to be within a function or at the top line of a module. So I've already written this. I'm just going to uncomment it because I clearly can't type without making typos or GitHub Copilot. So let's take a look at what it is. We have a const get data equals async, and then we have the bracket. So this is our arrow function syntax, or an ES6 function. We have to say async because we have an await in here. As soon as you type await somewhere, the function call has to be asynchronous. If I get rid of this, immediate complaints. So then this arrow is just points to the method body, and then we have our function body here. Const my data equals await fetch on this endpoint. So this is the same thing that's happening. We're going to this at endpoint, we're fetching that JSON object, we're storing it in my data as a constant. Then we are applying the .json method to turn this promise into an actual JSON object. And then we're going to log the object. I think this is more readable. What's up?
So even for something like converting it to a JSON, you would await it just to be safe when you printed it?
For that particular call, the .json call, you have to.
You have to, okay.
Yeah. It depends on what methods you're using and what form the data is. But for this specific, this .json method, if I take this away, I was actually going to say, what do you guys think will happen if I do this? This was actually my next point that I was going to do. And then I call get data. Any yeses? What's up? I'll get something. It just isn't going to be useful. Promise pending. Because we didn't await this, we then, what happens is on line 18, we try to print this JSON. It hasn't been resolved yet. So we're just printing out promise pending. This is completely useless to us. We have to await. If you ever see promise pending in your code, and I promise you will, did not do that intentionally, just throw an await in there. It'll probably fix it. Likewise, if we do this, what do you think happens? This one's a little trickier.
No JSON.
We're gonna have an error here. What's happening is that we're trying to do await my data.json. My data doesn't exist yet. So if I run this guy, I'm so sorry. I thought it was that. That's what this error was. I'm not starting const my data equals fetch. There we go. My data.json isn't a function. My data just doesn't exist yet. The more awaits you take out, the more things are going to break. And the one thing I will say, we had the dot catch when we were dealing with promises directly. Instead of a dot catch dot then, we just do try catch. So the better function of this would look like this. So same exact things are going on with the await fetch and then await my data.json. However, if we catch something, yeah, what's up?
Dumb question. How
Yeah.
do you comment every what do you put on the keyboard to comment every single line of the animation?
Command and the question mark.
Oh.
I do a lot of terminal tricks, I think. So if you guys see me doing something, just holler, okay? Please. So, not a dumb question. That's a great question. The only difference here is we're catching an error, and then we'll just console log it. Obviously, in an actual application, we want something more robust. This finally method, I think it exists in Java or regular Java. I don't think it exists in C++. I could be wrong. What that is going to do is if I call this guy, basically means regardless of if we try or catch, whichever one ends up executing, just do this last thing at the end. So if I run this, it should say, if I have no errors here, it'll give me the JSON, it'll log it out, and then it'll log, thankfully it is over. Cool. So hopefully that answers some questions. This stuff gets a little bit more intuitive when you start working with it yourself. Most of the time, it's just const the data equals await, do the thing, is what it's going to be in like 80% of your cases. So does anybody have any other questions? This is a really important topic. Okay, I'm going to move on to TypeScript.
Wait, can you go back?
Yeah, of course.
Sorry, I didn't have it all written.
Yeah, no worries. Tell you what, I'm gonna toss this into Slack for you.
Oh, I already have pretty much all of it down.
Well, now you got all of it.
Thank you so much.
Oh, good. So JavaScript has a lot of problems. I mentioned this before. There have been a bunch of different attempts to try to make JavaScript less horrible. CoffeeScript, I've never written it. I don't even know what it is. I know that it exists. Flow, probably never heard of it. Dart, I know for a fact that there are people in this room that do Dart. Dart, all of these just compile down to JavaScript. So what happens is you write the language of Dart or CoffeeScript or whatever. There's something called the transpiler, which just turns it into actual JavaScript. We'll see this in TypeScript in about 10 minutes. Yeah, TypeScript is the one that won. All of these are pretty outdated with the exception of Dart, which is in use, but it's not nearly as widely used as TypeScript. So the problems with JavaScript, static typing. We went over this yesterday, or it doesn't have static typing, excuse me. Anything can be anything in JavaScript. I showed you some examples. It's not great. And for the people, and this was actually my interaction my impression when I switched to TypeScript, it was, oh, well, it's easier to write. I don't have to spend time making types. Well, if you don't know how to make the type correctly, you would have been dealing with the wrong form of data anyway. And the only question is, are we catching the error before we write it, or are we catching the error when we're trying to debug later? So TypeScript also, or JavaScript also doesn't have great tooling in autocomplete. If I have an object called myObj, and I type in myObj dot, and I'm looking for some property like dot city dot location, or something like, or anything like that, the tooling for TypeScript and the error messages for TypeScript make developing much faster. What else is cool about TypeScript is you get to decide how TypeScript your TypeScript is. I'm going to teach you something that's about the middle of the road. If you're working at like Google, you don't have a choice. It's just got to be max strict all the time. So something else that's kind of cool about it is that you can actually target how it compiles down to JavaScript, or transpiles, excuse me. And it gives you backwards and forwards compatibility. So I'm just going to jump into it. I don't want to talk too much. I'm going to make a new directory here, and we're just going to get after it. So if you guys can open up just a fresh folder, because we're going to install some dependencies here. So the very first thing we do, I'll actually give you guys a second. Has everybody opened up basically just a fresh instance of VS Code somewhere? Anybody need more time? Okay, so the very first thing we're going to do is we have to actually install TypeScript. We can't just start typing it because it has to turn into JavaScript. TypeScript is a dependency. So what I'm going to do here, I'm going to use our Node package manager. So npm install TypeScript. Boom. Immediately, we get three things. We get node modules, not important for now. We get a package lock, not important, and we get our package.json, which shows all our dependencies. For now, it's just TypeScript. Perfect. So we now have to initialize the project. Has everybody actually been able to get this going with TypeScript? Please holler if you're not. So the next thing we have to do is actually initialize TypeScript in here. So it's just going to be tsc -- init. We now get a TypeScript config.json file. There's a lot in here. This is going to be the default one for when you initialize something. All of these options are how we actually set up our transpiler to turn it into JavaScript code. What's up?
Sorry, the TSC command is not working for me. I don't know if people have the same issue.
Can one of you guys?
Yeah, I also have command not found.
Did you npm install TypeScript? Is everybody having this issue? Thank you for letting me know. You got any ideas? I was going to do a global installation. Guys, we're going to install it globally as well. That might be what's going on. So npm install G is just a global installation, TypeScript. Oh. What's up? It's working? Okay. Usually you should try to install avoid global installations of packages or dependencies. In this case, sure. If it works, it works. Are people still having issues? Yeah. Okay. What are you getting when you type in install npm install -g TypeScript?
Added one package, the G1?
Yeah, with the G1.
Added one package in 846 months.
Cool. And then if you type tsc -- init, what happens?
TSC -init -tsc command not found.
Interesting. For now, I don't want to take up too much time on this. Leo, if you can, oh boy.
I'm on Stack Overflow.
You're on Stack Overflow? I set this up on a new machine yesterday. I tested it with no programming anything on it, and just installing locally did it for me. Okay. I apologize. I'll talk to you after class. Right now, I do want to move on. So we do have our TypeScript config file. Most of this stuff is commented out. Most of it I honestly have never touched in my entire life. There's some stuff in here that's important. I'm actually going to copy and paste one that I use fairly frequently into Slack here. You can also check this out if you just want to go to the repo. It should be on there. You guys got it? You got it?
If you npx it, it works.
Oh, npx, thank you. Okay. Cool. So I'm going to literally just drop in the one that I like to use. And we are over here. Cool. So a couple things going on that are important. The most important thing is this outdir. Outdir refers to where the actual TypeScript gets put when you compile it down. We'll see this in a second. This should pretty much always be your dist folder. I've never seen it not be this way. And for whatever reason, when you init TypeScript, it doesn't set it up like this. It's kind of terrible. Another important thing, which we're actually going to be changing here real quick, is this include. This is what files is it actually looking for to transpile down to JavaScript. So we're actually going to have to change this because I don't have a source folder in this directory. So if I just do this guy, I think this should do it. I believe that'll do it. If it doesn't, I'll fix it. And a lot of these we can cover if we get time, but dist is the most important. So let me make my first script. TypeScript. I'm just going to call it scripts.ts. You can call it whatever. Actually, please call it scripts. So it's just a .ts file. Now, the important thing to know is that all TypeScript is JavaScript. I'm so sorry. All JavaScript is TypeScript. We were talking about how strict you can be. If you don't do any types whatsoever, that's still valid TypeScript. It's just not very TypeScripty, and it sort of defeats the purpose. So if we do const number, or not number, you can't say number, const data equals 7, that's TypeScript. It's also JavaScript. But we can do const data number equals 7. So we do not do, like in C-style languages, you don't do int data equals 7. No good. There are no ints, there's no longs, there's no shorts, it's just numbers. Actually, I think there is a long, but it's called something else and you never use it. Yeah, so the cool thing, this is it. This is what TypeScript does for us. I know this is really simple and a really simple example. Immediately, something's wrong. Our compiler is yelling at us, or our VS Code is yelling at us. Number is not assignable to type string. Let's try number again. Cool. So if we want to actually turn this into JavaScript code, TSC, let's see if I got this right. Boom, we get this dist folder. Now, the dist folder compiled two things. Compiled scripts.js, so this is what will actually run. This is the JavaScript that was introduced from the TypeScript that we just wrote. You'll notice that it has the same name. It's also scripts.js.map. You don't need to worry about this. If you see errors, like 4As, MAAM, anything like that, on your front end, it means that you've seriously messed up how you're running your project and you're probably running uncompiled files or old files. So what we can do, there's a couple handy commands. tsc-watch is a really cool one. Because what happens now, every time we want to run, or actually before I do that, every time we want to run this, we can do /node for running it. I love the fish shell. /dist refers to that folder. Scripts.js refers to that file that we just compiled. So this should say, well, it won't say anything because we didn't console log anything. If we want to do a console log here, and we try to run that script, nothing will happen. We have not yet recompiled it down to this JavaScript. You can see this JavaScript file still says const data equals 7. This TypeScript says, has a console log. How do we fix this? This is the watch command. Now, every time we save a file, it'll retranspile down to the JavaScript. So I'm just going to save this real quick. Scripts.js should have been updated. Great. So when you're running TypeScript, you should always keep a tsc-watch running. It will make your life a million times easier. I'm actually going to add a script to that in my package.json. So in your package.json file, we'll talk more about this later. You can add lots of stuff, including scripts. So one script that I want to do is, let's call it watch. What was I doing? Node. Nope, it was just tsc -- watch. So now if I type, let me just open up a new terminal. I'm going to kill this. If I type npm run, that's just the script that we want to do, watch, we're now watching. These scripts are really, really useful for your dev experience. I recommend, if you're not writing them yourself, look up what some handy ones are. I can probably drop a link in the Slack after this class, and include some ones that I use pretty frequently. So let's do run. So if we want to run, typically your run command or your start command would be at your index.js file. We don't have index. We have a node./dist/scripts.js. If there are no typos, what will happen when I type npm run start? Cool. Does anybody have any questions about these scripts real quick, or what's happening with the JavaScript file and its relationships in the TypeScript file? Awesome. Now we're going to start writing TypeScript. So the two types that you'll use the most are strings and numbers. Const data number equals 7. Const my string equals hello. Cool. Simple enough. Nothing special going on there. Let's talk about functions and return types. So we made an adder the other day. So const adder equals a. So a is a number here. B is a number. It's going to return a number. So that's the return syntax. It's just a colon and then the type that you're returning. We do our arrow function. We include our braces. We return a plus b. I know it's just adding a plus b, but here's why TypeScript really shines. If we try to call this adder 1, 1, immediately we're getting yelled at. And it tells us exactly what's wrong. String is not assignable to parameter of type number. Does not work. If we try to return, does not work. It's expecting a number to be returned. And so on and so forth. Generics also exist in TypeScript. If we want to make this adder function a little bit more robust, what we can do is use generics. I'm actually going to fix this with a specific type. This doesn't work for the adder function, simply because adding is not defined for generic types. But if we wanted to, for example, return void and log a, we now have it defined for generics. So the coolest thing about TypeScript is that you can make your own types, and it takes about 3 seconds. Let's say that I have some application. I have a username as a password, a username, and maybe a date of birth, age, let's say. So type user, we give them capital letters, equals, and then it's just, this follows JavaScript object notation. So we have our brackets, we have age, number, semicolon, name, or username, I think we said, string, and password, string. That's a user. So if we try to, let's say we're trying to deal with manipulating some data, and we have const my user of type user, and then we're trying to define it here. Let's say age 22, username colon, password, also colon. I'm not 22. And typically, when you see one line has an underline under it, usually you forget a comma. So this is fine. If we get rid of password, this is not fine. We've said that user has 3 attributes. It must have all 3 of those attributes. There's no password here. Let's say that user is KG. And doesn't want to type in their age. And that's okay. Sometimes we store users' ages, sometimes we don't. Well, if you don't put a user in there, again, error. So how do we resolve this? This is a really cool feature that this language has. It's just a question mark. This is just saying, you can put this field in. It's optional. You don't have to. So, no errors. Simple enough. Please just shout out if you have any questions. We got to move pretty fast for the last like 25 minutes. I'm just going to keep moving. So, there is also something called an interface. It is, for the purposes of this class, identical to a type. There are very, very, very tiny niche differences between the two. How I'm going to tell you to use them and how most people will use them. Interface my user to, or just user to. The only real difference in how you declare them is that there's no equal sign there and you type interface. So here's how we're going to do this. If we have a type that we're going to be using frequently throughout the project, we need to put it somewhere else aside from this one file, because then it's awkward to get to. So I'm going to make a new file here called types.ts. I'm going to put in my user. And if I want this to be available to other parts of my program, I need to export it. Cool. So now I can get that with an import statement. Now you'll see this doesn't know what user is. Here's a VS Code trick. You can type in like import and type it out exactly. For people on Macs, command, period. Oh, I'm so sorry. I've done this 10 million. Yep, it is command period. Add import from types. Cool. Don't have to actually ever type that. So now it knows what our user is. It's defined in our types.ts. Typically, if we're having a lot of types that are going to be used throughout our application, we put them all here. There are different ways that people will tell you to do this. This is how we're doing it. So the only difference between types and interfaces is I used to like to use types for things that go everywhere. If I just have an interface for something that I'm going to use 1 or 2 times, or something I'll just use once or twice, I'll make an interface directly before I use it, and then I'll use it right there, and then I'll just forget about it. That is actually the more performant way to do it if you care about minor, ultra minor optimizations. So now we have this user. Let's say that we have some function, return user. You know what? I'm going to make it even easier. Const my function equals name, username. Or sorry, username is string. We said age is number, and password also a string. This is going to return, let's say that we want to, I don't know, log someone in. And once we log someone in, we're going to either want to return that user so that we can work with it, or we want to return an error that something went wrong. To my knowledge, there's no graceful, easy, quick way to do this in a language like C++. But let's say that we have an error type. I'm just going to make an error type here real quick. You can't call it error. It's a protected keyword. My error. Message, string, and severity. Let's say it gets a number for how bad it is. So like 10 would be really bad error. 1 would be not so bad. So let's say that we want to log someone in, or alternatively, give an error. So if password2 string. So if password1 or password equals three equals password 2. So let's say like we assume that they're good. We can log in the user. So to return a user, say that we're returning a user here, we're going to need to return an object with a username. An age. So here's the thing. With TypeScript, this is great. You type in one letter. It gives you the fields that can possibly be there. I just type enter. Age. And then finally, the last one was a password. I type in P. It already knows. Password. And then password is what we passed in. So now we're returning a user there. Why is it complaining? Well, there's no ending return statement. There are some paths that don't lead to us returning a user. This could potentially be a bug. So what if we want to return an error? Else return, I'm just going to make the error so I'm not returning it like that. Const new error. We called it my error equals message. Before I even get into this, I'm going to import this type. So command period, update import from types. So the my error type has a message, passwords don't match, and it has a severity, I believe. So I type in S, I get severity. Say this is a 3, it's not that bad. I just typed, I saved, that's why it formatted everything like that. So now I'm going to want to return else const error, so I'm going to want to return that error. But this is a problem because we said we're returning a user. How do we return a user or an error? I've always wanted to do this in stuff in C++. It's just hard. TypeScript makes it easy. Or my error. Problem solved. I'm going to go over that in a little bit more detail. This is like the most important feature of the language, in my opinion, is type union, is what this is referred to. We were saying we are returning a user or we are returning a my error. It can be either, but it must be one. What we can also do is continue stringing this. So let's say that we wanted to potentially return null. Let's say that that's something we might want to do. We can return null. Null is a type in TypeScript. Works the same as C++, Java, etc. You'll use it all the time. Let's say we want to return undefined. We can do that. Yeah, so you'll see all the time, all over the place in TypeScript, you get an option for type unions. In JavaScript, you don't have to do any of this. You don't have to set up the return types. You don't have to set up the types for your parameters. You can just say return this, return that based on the logic, and that's great. And it is a little bit faster to write, but as soon as something goes wrong, you're spending 30 minutes debugging something that took us maybe 3 seconds to write. So hopefully you'll start to see the value of TypeScript. I want to talk about type intersection. Type person equals name. Everybody has a name. It's a string. Oops, sorry, that's wrong. String. Type employee equals every employee has a salary. Don't work for free, guys. Const. Let's say Jim is a person and employee. So, doesn't like this because we haven't given him any properties yet, but as soon as we give him a name, Jim, salary, Jim's loaded. So now Jim is both a person and an employee. We can do the opposite of type unions. It's just a type intersection. Does anybody have any questions? Cool. Am I moving too slowly? What's up, Gordon?
The types have overlapping attributes. Did that cause an error or something? Like employee and person have a name?
Nope.
What would it choose? Or would it have both?
Well, it doesn't choose if they're the same. If person is a name and employee has a name, it can't choose. So you're saying like if name is a number over
Like
here.
you say Jim.name or whatever, yeah.
So if the types don't match, immediately VS Code yells at us.
Okay.
Immediately. But Jim doesn't have like a person name and an employee name. As long as the types match and both types in the type intersection are okay with each other, you're set. So let me see what else I wanted to talk about real quick. This was like most of the basics. So, TypeScript also has classes. I don't want to spend much more time on classes. It works the exact same way as classes in JavaScript. Key of, okay. Sorry, too many windows open, guys. So key of is just literally going to list the fields. So if I type key of const list of fields, key of employee, okay. Here's what key of does for employee. If we look at employee, it's got two fields, salary and name. My list of fields variable, I can just call it like, I don't know, anything, it doesn't matter, is of type key of employee. Key of employee is a list. When you see key of, just think list in your head. It is a list of all of the fields of employee. So the fields of employee are salary and name. So that's all ASDF can ever equal. It can equal salary, it can equal name, it can never equal anything else. Immediate error, right off the bat. You don't even have to wait. What we can also do, something that I did want to mention, is the function type of. So if we have data, it's a number. Let's log the type of data. And something that I think you should probably try to get into the habit of doing when you're writing HTML or JavaScript or TypeScript, just press Command Save or Control Save every 3 seconds. It's going to format stuff. It's going to autocomplete stuff you don't want to type, specifically like semicolons and stuff. But if we do type of data, this will literally type out number. Cool. So this is actually, I find myself mostly using it for debugging, but one way in which it's also very useful is if you're dealing with some data and you don't know what it is, you can simply do, like let's say I get some object passed in and I don't know what type of object it is and I know it's a person or it's an employee. I can do if type of object is equal to person, we're good. Do this logic there. Otherwise, do the other logic. So type of can be pretty important. So some people would yell at me for what I'm about to tell you. There's a word in TypeScript called any. Any is, Leo's frowning at me because I think he knows what I'm about to say. If you work for Google and you ever type the word any at every given point, they'll never approve your code. Like it's in their style guide. You can't say any. Any is used to mean any type of object or any type. It's the equivalent in Java of capital O object. It just covers everything. So for example, if I have const number, let me show you the adder function again. Cool. So now this is useless. We have undone the entire point of TypeScript. A can be any type, B can be any type, we can return anything. This is no good. The only reasons in which you should ever use any, ever, for any reason, is if you are dealing with an outdated module that does not have its type set up, like someone else's code that you just npm installed and they never did TypeScript on it, you may have to do any. That's not the end of the world. If you get a type that is wildly complex, let me show you real quick, and this is where you really, it's not great to do. Let me pull this type up. 2 seconds. So here's a type that came up for me recently. You can see the problem. This is unreadable. This is garbage. If you want to avoid having to think about doing something like this, you can type the word any and make your problems go away. The downside is that they might come back later when you have a bug and you aren't sure how to fix it because you're not sure what the type is. What you can also do is there's a word undefined. Undefined works very similar to any, it's just a little bit different. So if I have you can see a difference. It does like one of them, it doesn't like the other one of them. Any is loosey-goosey, JavaScript rules go. However, undefined, you can't assign things to undefined in this manner. When an object is undefined, you can't modify it. I have read Google's style guide in preparation for this class. They do let you use undefined. They will never let you use any. Yeah, it's something that should be avoided whenever possible. You want to stay away from these keywords. I'm letting you know because they will come up. Some other keywords that are important. So sorry, give me 2 seconds here. Types, interfaces, type of union, undefined. We talked about null, we talked about any, as const. I'm going to link you some code because there's no real way to show what this means without linking code that you're not fully going to understand yet if you haven't done React. But there's no other situation in which this comes up. And I apologize in advance for talking about React a week early. Oh. There it is. So there's going to be a lot of red squiggles here. This is all either functions that I haven't declared or stuff from React that's not going on. Here's what as const is. If you have some variable that you needed to have as a variable to create, I mean that you can't say const number. You have to work with it. It has to be a let number. It has to actually vary. It can't be final or const. Did you have a question? Sorry. But then we have to return it as a constant that in a way that can never be mutable or changed or anything like that. When you see these arrays with like 2 things in them, that's like classic React. You'll see an array, thing 1, thing 2, and a lot of times it's called noun, set noun. Because of how React works, these are immutable. You can't change them. To change them, you have to do these different rules, which we're going to talk about later. But this was a variable, and if I just returned it as it was, my compiler was yelling at me and wouldn't let me actually save this function. If you type as const, it makes it clear to your compiler, so the React stuff won't complain, that this is in fact a constant. It'll make your errors go away. This one was really, really hard to figure out the first time I saw it and had to diagnose it, so hopefully this guys can save you guys something of a headache. But when you're doing React, as const comes up a lot. Classes, exporting types, Kiev. So we talked about exporting types, perfect. I think we've covered everything on TypeScript I wanted to do, but we need to talk about arrays in JavaScript just a little bit because we didn't get to them yesterday. So JavaScript has some native methods to arrays, or for arrays, which I think are really, really incredibly useful. Right now, Leo, favorite array method? I'm so sorry. I won't do that again. .map is like the coolest thing in the world. It saves you so many headaches. It basically is a method that's mostly written for you. Let me show you how it works. So let's say we have an array. Let's say that this is a const my_r. Let's say that this is an array of numbers. So this will look like this. Equals 1, 2, 3, 10. Okay? So that's just our syntax for arrays here real quick. Number and then the brackets. You can also write arrays in a different way. It doesn't matter. It's just different ways of writing the same thing. my_r.map. You'll see it gets a star. VS Code means it knows that star methods are important. They come up a lot. So here's what the map method does. It takes every single element that's in this array and it does something to it. So we're just going to call it, you can't call it, or really shouldn't call it number. We're going to call it data. So this is a function, so that's our parameter. So we have the function, we have our arrow. Let's just do console.log, oh no, I'm sorry, we're mapping. Data is, I was doing the for each. Data times 2. I did something dumb. Give me a sec. Anyone see it? Thank you. It was dumb. It's been a long week, guys. Cool. So here's what we did. Thank you, both of you. So my_r.map takes data. So it just parses, or it steps through this array, and it looks at each individual element, and it does something to it. So we take data. So at index 0, data is just 1. Returns data times 2. So it'll be 2, 4, 6, 20. Basically, this is a way of mapping one value to another value. Now, it doesn't have to be the same thing. It could be return so this is mapping a number to a string. We'll see this in React where we map pieces of data. They could be strings, numbers, users, whatever. We're going to map them to actual HTML components and then throw them up on our page. It is my favorite part of React. I think it'll save you guys huge headaches. There's actually a lot of other array methods. We have 4 minutes. Let's do for each. So for each basically just means for every element in this array, do something. So same syntax. This is a method, so it's got to have our method call, or our brackets around it. We can call it the input. We do our arrows for a function. Let's just log this. So this should, for every single element in this array, console log the input separately on its own line. So this should be line 1 is going to be 1, line 2 is 2, line 3 is 3, and line 4 is 10. Perfect. If we just actually printed out the array, so that's sort of how we know that we're going from an array to individual numbers there. Now, of course, because this is TypeScript, you would think that you would be able to have types, and you would be correct. So let's say input should be a number, should be returning void. Now I know this looks a little bit different than the syntax that we just used with the arrow functions, but basically this is a function. We just didn't give it a name. It's an anonymous function here. These are our parameters. I just want you guys to get used to this idea because these are weird and this took me a while. You guys are hopefully probably smarter than I am and can pick it up way faster. Parameters, return type, actual function. It's a little bit odd because it's inside a function. And the very last thing that I wanted to talk about, I have about 2 minutes because you will use these. So far we talked about types. We had simple types. We had numbers, strings. We talked about type unions and intersections. We can also have something cool in types. We can have a function being part of a type. So what this means is that in errors, every error has a function that's part of it that does something. And what this function is going to do is it's going to take no parameters, it's going to return nothing. So over here in scripts, if we want to define an error, what do we have? We had message. And the function should be let's say, so you can't return anything. I'm just going to do a that's why I wasn't getting my, so you guys saw that I was mousing over stuff and not getting type autocomplete. It's because I didn't import it at first and that was a mistake. So we've actually assigned a function to this object. This object has a function in it, but we can make a myError2 that does something a little bit different. It's important to remember that this function is not specific, or it's not for every single myError object. They just have to follow the pattern of no parameters, return void. So this could be can't wait until break. These are two different functions. But as long as they follow that same constructed format, we're good. We ran a little bit over. Does anybody have any questions real quick? Absolutely sick. Great work, guys. I will see you after the break. We're going to start talking about React. If you haven't turned in your website yet, please do it. We want to see them. And yeah, thanks, guys.